Increasing and decreasing functions. Differentiation, Unit 7, Example 3. Finding the values of x, domain, for which the function y equals x cubed minus 6x squared plus 9x plus 3 when x is greater than 0 is increasing. Whenever we're looking for increasing or decreasing or stationary, we always use dy dx. I'm just going to show you from a graph point of view. If I'm plotting not y, but the y, the x on the y-axis, and x on the x-axis, it is important that the positive part of this graph, the dy dx, the positive implies that dy dx is greater than 0, and that's a positive slope, and that's increasing. And the negative part of dy dx below 0 here is less than 0, as we can see, because this is 0, this is less, and that's a negative slope. And the horizontal part here, the x-axis here, and that's when the y, the x, equal to 0, and that's stationary. So the x-axis is stationary. The question is asking us for increasing function, so we're looking for that. This is negative dy dx. This is positive dy dx. What we're looking for when x is greater than 0, so from there to the right, that's what we're looking for. We got a function y equals x cubed minus 6x squared plus 9x plus 3. In order to find dy dx, we need to make sure that the function y is in the form of x to the power of n, then dy dx will be equal to n x to the power of n minus 1. So that's the process we use for calculating dy dx. We got this function here, so let's make it look like this. This is 1, 2, 3, 4. We got 4 terms here. So y equals x to the power of 3, well, that looks like that, good, minus 6x squared, that looks like that, that's good, plus 9x to the power of 1, that's good, plus, well, 3x to the power of 0. If you see a constant, it has the same variable as the other terms, except that the power of the variable is 0. Now we know that anything to the power 0 equals 1 in maths. So now we can apply this function here. We can then apply it to dy dx. So dy dx will be equal to, in this case, 3 times 1, because there's 1 here. So that's 3x. Then 3 minus 1 is to the power of 2, minus 2 times 6, that's 12, x, 2 minus 1 is 1, x to the power of 1, minus 1 times 9, so actually that's plus here, plus 1 times 9 is 9, x to the power of 1 minus 1, 1 minus 1, that's 0, plus 0 times 3, that's 0. So that's gone. So now we get dy dx will be equal to 3x squared minus 12x plus 9 has to be greater than 0 for increasing function. This is increasing function. Has to be greater. That's a positive gradient. Has to be greater than 0. This is a negative gradient. And then we could actually divide both left and right by 3 to simplify it. So that would be x squared minus 4x plus 3 is greater than 0 divided by 3 is 0. So we need to factorize this. So that reminds me of a quadratic, which is ax squared plus bx plus c, in this case greater than 0, where a equals 1, that's 1 there, b equals minus 4, and c equals 3. So I want to find AC. So to find AC, and the AC equals 3 because 1 times 3 is 3. I need two numbers I can multiply together to get 3. And when I add them together, I get minus 4. The product is 3 and the sum is minus 4. So I want minus 1 minus 3. And when I sum them up, I get minus 4. So that's B, minus 4. That's good. All I need to do now is multiply minus 1 by x. So that's minus x. Minus 3 by x, I get minus 3x. And that will give minus 4x. So I'm going to replace minus 4x here with minus x and minus 3x. I'm going to get x squared minus x minus 3x plus 3 greater than 0. I can see there's a common factor here. That's x. And another common factor here, minus 3. So if I take x out, I get x minus 1, close bracket. X times x is x squared. X times minus 1 is minus x. If I take minus 3 out, because this is minus, I have to take minus out. And 3 is common, so take 3 out. I get x minus 1. Because minus 3 times x is minus 3x. Minus 3 times minus 1 will be plus 3. You see, whenever you take minus out, the sign next to it will change. Now I can see a final common factor, x minus 1 is common, and I'm left with minus x minus 3. So those will be my factors. X minus 3 and x minus 1 greater than 0. If I set this to 0 and set that to 0 just to get the roots, these are the factors. To get the roots, that will be x minus 3 equal to 0. X equals 3, right? X minus 1 equal to 0. X equals 1. So these are the roots for the quadratic of the dy dx. So what I need to do now is try and sketch the graph. Remember, the y-axis is dy dx. So that's dy dx. I'm plotting dy dx against x. Whenever we're looking for increasing function and decreasing function, we always compare it to dy dx. I can see x equals 3, so that's 3 there. And x equals 1, so that's 1. And I can see that it crosses the y-axis if you're sketching quadratic at 3. Because when x is 0 here, dy dx is 3. Or 9 if you're using that one. But I'm using these. So that'll be 3 there. So my curve will be going all the way there. And this is 0 here. I know this side is the y, dx greater than 0. So that's a positive slope, right? And the bottom here is dy dx less than 0. So that's a negative slope, right? And don't forget the stationary. This line here along the x-axis is stationary. And that's dy dx equal to 0. It's always equal to 0 at stationary. So where is dy dx positive, increasing, when x is greater than 0? See, x is greater than 0 here. So this is positive here. The positive side here is going to be these ones. And not there, but here. So those are the two sides that's got to be positive. So what's their range? Or what's the domain? The domain for these ones here are, so you could say x colon 0 is less than x because it's between 0 and 1, which is less than 1. Open curly bracket and close, open curly bracket and close curly bracket. Union, that means plus, open curly bracket, x colon. Now x is greater than 3. So you just say x is greater than 3. Close curly bracket. And that's the answer for that question. Because it's asking for when x is greater than 0. So that's what it's asking for.